So the mean is the most common average. It's found by adding all the scores together, then dividing by the number of scores. Sum of the scores over the number of scores. It does not always represent data correctly. And two different kinds are a population mean and a sample mean. So a sample is a subset of scores, and a sample size is the total number of scores in the sample. And a sample mean is a balance point for a sample. And the formula is under here, x bar equals the sum of the variable x divided by the sample size m. Uppercase Greek letter sigma stands for the sum of, not sigma, and in a sample includes all duplicates too. Population is a complete set of subscores. Population size is the total number of scores in the population. And the balance point for a population found by dividing the sum for all scores in the population by the number of scores in the population is population mean. And the formula is here. Mu equals the sum of all the scores divided by the population size, n. And what's the difference between sample mean and population mean? They're both the same, just different symbols. One is for samples or a survey, and the other is for an experiment or population. The mean serves as the balance point for its frequency distribution. And the sum of all scores expressed as positive and negative deviations from the mean always equals 0. And it talks about that here on page 65. The mean reflects the values of all scores, not just those that are middle ranked, as with the median, or those that occur most frequently, as with the mode. And the progress check is right here. And it asks you to find the mean. So you add all these numbers up, 60, 63, so and you get 675, and you divide by 11, because there's 11 numbers there, to get 61.09. And I usually round it to however they like. So because it goes to the ones place, I get 61. Then for 3.6, you can add all those numbers. 6 there. They add 163.3, and you divide it by 6 for the number of data there, and you get 27.22. And then I again rounded to 27.2 because I rounded the data to the nearest tens place.